Hi, Chelsy. How are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So, how's your test on trigonometry?
I had a quiz today. It was good. And then on chapter 6 of the Nelson textbook. And then Friday, this coming Friday, I have a combined test on chapter 6 and 7.
Perfect. So, you need to learn that chapter 7 now, right? You're done with questions on chapter 6. So, in
Mhm.
chapter 7, what is it all about? Can you just share whatever you have and then we'll talk about it?
Yeah. A moment, I'll share my screen.
Yeah, share your screen. So, it's compound angle formula. You have sine alpha plus beta, cos alpha plus beta, and tan alpha plus beta formulae. Do you remember them?
I need something to help me memorize it.
Okay, that's fine. So very important formula. We have to remember them for doing any questions on this particular unit. And so first thing will be to focus on how do we remember the compound angle formula, right? So let me show you how. It'll be very easy for you to remember, just as I remember them for ages. Do you understand?
Mhm.
So let me begin with sine, right? So sinusoidal functions starting with sine. So sine, you're using alpha and beta. Let me use alpha and beta. Sine alpha plus beta is basically equal to sine alpha cos beta plus cos alpha sine beta. Is it okay?
Mhm.
If we have sine of alpha minus beta, in that case, the only change is this particular sign. So it becomes sine alpha cos beta minus of cos alpha sine beta. Is that clear to you?
Yeah.
Easy to remember. Let's call them formula number 1 and 2, right? So you call them as 1 and 2. Now, similarly, let me write down the formula for cosine. So what is cos of alpha plus beta equal to? So we have cos alpha cos beta minus sine alpha sine beta. You see the major difference. When we have sine of compound angles, then the terms are sine and cosine with the positive sign.
Yeah.
However, when we have cos of compound angle, then we have cos sine with a negative sign. So that is how they are different. And if you remember this difference, you can always remember the formula, right? If I have cos of alpha minus beta, in that case, it is cos, right? So cos plus in between and sine. Do you understand now how to remember that? Is that clear to
Yeah.
you?
So it's they're flipped.
Yeah, they are flipped. Now, one more important thing which I'll show you quickly on these formulae. So we'll call this as formula number 3, and this will be 4 for us. Now, what happens when I add 1 and 2? So if I add 1 and 2, I do get here, let me use another ink here. We do get sine alpha plus beta and plus, we are adding them, right?
Mhm.
Sine alpha minus beta. So when you add them, what do you get? These two terms, which are positive and negative, will cancel out, correct? And the first term, sine alpha cos beta, will add up. And so it will be equal to 2 times sine alpha cos beta. Do you understand now? So when you add the sum and difference of these compound angles, then you get 2 times sine alpha cos beta. Do you see that part?
Yeah.
Right? On the other hand, if I add cos alpha plus beta with cos of alpha minus beta, what do I get? The first two terms are cos alpha cos beta, right? So we get 2 times cos alpha cos beta. Do you see that? So we are getting formula number 5 and 6. You will learn them soon.
Mhm.
Let me go one more step here. If I put alpha equals to beta equals to, let us say theta. I'm writing alpha beta as theta. Is it okay? So what is sine alpha plus beta? It is how much? Sine 2 theta, right? Alpha and beta is theta, right? So we have theta plus theta. Is it okay? And here, what do we get? We have plus sine of theta minus theta. I have substituted alpha and beta as theta. Is that okay?
Okay.
So
So
I
could you
get
repeat that one more time, sir?
yes. So okay, let's go back. So I'm substituting alpha and beta both as theta. Do you see that?
Okay.
So if I do that, I could actually substitute in the first formula also, right? Substitute this in one, let us say in one, in my first equation itself. Is it okay? Let me do it. So sine alpha plus beta becomes sine theta plus theta, right?
Yeah.
Equals to how much? Sine theta cos theta plus cos theta sine theta. Both are same terms, right? Is that clear?
Yes.
I get sine 2 theta equals to 2 times sine theta cos theta. Sine 2 theta I got as 2 times sine theta cos theta. Do you understand this part?
Yes.
So I got double angle formula. So this is called double angle formula. So I have already got a sum of combination and I have got double angle formula. So I have got from the same thing, couple of formula here for you. So this I'll call as formula number 7, right? And this is sum to product. This formula number 5, we call this as product sum to product. For a reason. It is adding sine alpha plus beta plus sine alpha minus beta is 2 times sine alpha cos beta, product of the two. Do you understand?
Yeah.
So from compound angle, we got sum to product formula, and from there we got double angle formula. And if I replace 2 theta with A, then I get half angle formula also from there. So which I'll not get into today, right? So we'll keep it up to this stage. Similarly, if I would do cos alpha and cos beta as theta, right? So what do I get? On this side, cosine, I have cos of, let me use a lighter color. So it's cos of theta plus theta equals to what? Cos theta, right? Minus sine theta, correct?
Yeah.
So that means cos 2 theta is basically equals to cos square theta minus sine square theta. You get the idea?
Okay. Yeah. So you're using the compound angles that we just have to remember to derive the double
other related formula.
Mhm.
So we got double angle formula. Now this cos 2 theta formula is extremely important because I could write it in 3 different ways. You know, what is cos square theta? Cos square theta is 1 minus sine square theta, correct? So if I write that, then I get cos 2 theta equals to 1 minus sine square theta. I'm writing that instead of cos square theta minus sine square theta. Do you see that?
Okay.
So that means
how did you get that from the cos 2?
Cos square theta is 1 minus sine square theta, right? We know what? Pythagorean theorem. Sine square theta plus cos square theta is equal to 1. That means cos square theta equals to 1 minus sine square theta, correct? And also sine square theta equals to 1 minus cos square theta.
Right. Okay.
So we could also write this as, if I write sine square theta as 1 minus cos square theta, I get a formula which is 2 cos square theta minus 1. So with cos 2 theta, I have 3 different formulae. Do you see on this page, we have 7, 8, 9, 10 formulae already.
Yeah.
So starting with these 2 basic formulae, which is sine alpha plus beta and cos alpha plus beta, we get everything. You understand? You should understand one more thing from here, and that is very important. What is sine of minus theta equals to? Minus sine theta, correct? So when I change plus to minus, this becomes minus because sine is odd function.
Okay.
And what is cos of minus theta? It is cos theta. Cos is an even function, right?
Okay.
You recall that? Odd and even function? look here. I'm just going to use this page to full. Let us say we have an angle in quadrant 1, right? If we know all values are positive, right? All are positive, correct?
Yeah.
However, you know the cost rule. So the cost rule says that cos is positive in quadrant 4 and sine in quadrant 2, correct? So when I'm talking about minus theta, let's say this is theta, right? So minus theta means you are going in the clockwise direction. Is it okay?
Mm-hmm.
So in this quadrant, cos is positive. It makes sense? Cos of minus theta is cos theta.
Oh, yeah.
And sine is negative. And therefore, sine of minus theta is negative sine theta.
Right.
Does it correlate everything?
Yeah.
Right? So those are the two important things which you should consider while doing this particular chapter. So everything which is there on the board for you at present is what you need for unit 7. You get the idea.
Yeah.
Now, let us do your questions. Okay? Good. So let me clear this screen. Is everything clear to you?
Mm-hmm.
Everything clear to you?
Yeah, I think so.
I'll clear the screen also. Perfect. Wash it out. Tan alpha plus beta, the formula is tan alpha plus tan beta over 1 minus tan alpha beta. And when you do tan alpha minus beta, minus changes to positive, positive changes to minus. Since you know tan is also an odd function, correct?
Mm-hmm.
Tan minus theta is minus tan theta. It is also negative in quadrant 4, correct?
Similar to sine, right? Just like
Similar
sine.
to sine. Correct. Very, very important to look at these things. In trigonometry, you don't have to remember, but you have to look at them very carefully so that you understand what we are talking about, right? So this angle is positive theta and this angle is negative theta. And you know, sine and tan both are negative in quadrant 4, correct? And therefore, both are odd functions, right? Sine of minus theta is also equals to minus sine theta, correct? Only cos of minus theta is same as cos theta. It is an even function, correct?
Yeah.
Now, so that gives you all the formulae. Now let's look into the question number 1. We have to find the cos of 15 degrees, right? How will you do that? Tell me. So it's a new exercise for you. You haven't even had a class on this, right? So how could you get cos of 15 degrees? 15 degrees alpha and beta is, you know, what is cos of 30 degrees? You know that?
Cos of 30 degrees?
Yeah, you know the exact value, right? If you make your special triangle, whose sides are 1, 2, and square root of 3, and this angle right there is 30 degrees, correct? So cos of 30 degrees is square root 3 over 2, correct? So you know cos of 30 degrees, you can find cos of 15 degrees if you do half of that formula, correct? But there is easier way to go about. 15 can also be written as combination of 45 and 30, correct? So I could say that cos of 15 degrees is basically equals to cos of 45 degrees minus 30 degrees. Does it make sense to you? 15 is 45 minus 30.
Yeah.
Now we can use the compound angle formula for cos A minus B, alpha minus beta, right? So that gives you cos of 45 degrees times cos of 30 degrees minus, it becomes positive, it's kind of reverse, sine of 45 degrees into sine of 30 degrees, correct? You know, cos 45 and sine 45 is 1 over square root 2, correct? And cos 30 degrees from this angle is square root 3 over 2. So plus sine 45 is 1 over square root 2 and sine 30 degrees is half. So from here, you get square root 2, 2 square root 2 as common factor. In the numerator, you get square root 3 plus 1. So that becomes your answer. You get the idea.
Yeah, I'm just lost on the second line after cos 15.
After cos, where I expanded, cos of 15 degrees is written as cos 45 degrees minus 30, right? 45 minus 30 is 15, right? This is clear to you?
Yeah.
I have expanded this using the compound angle formula. Cos alpha minus beta is cos alpha cos beta plus sin alpha sin beta, correct? Alpha and beta being 45 and 30.
Right.
So we
Okay.
wrote cos 45 cos 30 plus sin 45 sin 30. Is that clear now?
Yeah.
Okay. For 45 degrees, I'll make another triangle, and this time I'll use the rationalized numbers. You remember cos 45, I could also write the values as we could write this as square root 2, and 2, right? Multiply each side by square root, which is as good as rationalize. I could do that, correct?
Mhm.
Normally, which values you use? Use 1, 1 and square root 2, correct?
Yeah.
So let me just draw that triangle here in the bit. Normally, what we do, we write this value as 1, 1 and square root 2, right?
Yeah.
So that means for 45 degrees, or we can say pi by 4, if you're working radians, we get the value of cos 45 degrees as 1 over square root 2, right? Correct?
Yeah.
Which I've used here in my calculation. So I've used cos 45 and cos 30. Cos 30 using this particular special triangle, square root 3 over 2. So these two special triangles help me give all the values. Once I do them, I can write down my answer, correct?
Okay. So all you did was so we had the cos 15 degrees.
Yes.
And then to make it so that we could use the compound angle formula, you found an alpha and beta.
Yes.
So 45 minus 30 also equals 15 degrees. So then alpha is 45, beta is 30.
Yes.
And then you added that into the compound angle formula, cos alpha plus beta or minus beta.
Yes.
And then you subbed in the exact values that we know already.
Perfect.
And then you solved.
Yeah. Most of the time, when you get the result, you have to write it in the rationalized form, right? So rationalized form is I have to rationalize the denominator, correct? So let me put the power on. Okay. So now, at times, you may have to multiply and divide by square root 2. Since do you notice that square root 2 in the denominator?
Yeah.
So in that case, what do we get? Multiplying numerator, we will give us square root 6 plus square root 2, correct? And multiplying denominator, we get 2 times 2, which is 4. So many times in the book, the answer for this will be written as square root 6 plus square root 2 over 4. Do you understand? So answer could be that instead of square root 3 plus 1 over 2 square root 2, both are equivalent expressions, okay?
Okay.
So either this is also equivalent to square root 3 plus 1 over 2 square root 2. However, this is better since it is denominators rationalized in this particular form.
Right. Okay.
To avoid this rationalization at the end, I was telling you that you could use this particular triangle for 45 degrees where the sides are not 1, 1 square root 2, but square root 2, square root 2, and 2. So what I did was I multiplied each side by square root 2. So I multiplied every side by square root 2.
Oh, I see. Okay.
So I get what? Square root 2, square root 2, and 2 as shown here. You get the idea. You get the idea. So that may be required many times. So is this concept clear to you? How do you get cos of 15 degrees exact value?
Yeah.
So let me clear this and get to the next question. Next question is, you need to now find what is the value of tan of minus 5 pi by 12. How will you get this answer? Tell me. Minus 5 pi by 12 means where are you? Can you draw this? So you're almost at this point. This is minus 5 pi by 12, correct?
Yeah.
Now we know that this tan is odd function. So this is equal to what? Well, this is equals to tan of, if I write it in the terms of acute angle, then it is negative, right? Negative tan of 5 pi by 12. I could think like this also, correct? So instead of working in quadrant 4, where we know it is a negative value, we can write this as negative of tan 5 pi by 12. This is 5 pi by 12 in quadrant 12, in quadrant 1, which is positive value. Do you see that? So I have modified this particular question. And first step which I did was, I wrote that equals to tan, let me write minus first, right? So I wrote this as minus tan 5 pi by 12.
Okay, yeah.
It is an important step. You could do with the given question also, but sometimes the angles could be like, minus 25 pi by 12. Then you have to see what is the related acute angle, right, in terms of related acute angle, and then evaluate. You get the idea.
Okay, yeah.
If I write minus 25, minus 55, minus 105, then it makes sense. Get the related acute angle. That's the whole step. Now, we have to write 5 pi in terms of some combination which gives you exact values. Like if I write this as 3 and 4 and 1, 3 and 2, something like this, 3 and 2 can work for us, right? So look here, we have minus tan, let me use the ink differently, right? This will minus tan 5 pi by 12 is equal to minus tan, I could write 5 pi as 3 pi plus 2 pi, correct?
Yeah.
The idea is, why did I do so? I could write this as combination of alpha and beta. So 3 pi divided by 12 is what? And 2 pi divided by 12 is what? Pi by 4. Do you see? 3 divided by 12?
Yeah.
And 2 is pi by 6. Now I can use my special triangles and get the answer, correct?
Mhm.
So, sorry, pi by 4, I wrote 12 here. Pi by 4, correct? 12 divided by 4. So basically, now I'm going to use my special triangles. So 2 triangles which are normally needed in this exercise. And you should always make these triangles even before you start answering the questions, right? So if I'm talking about pi by 4, we're talking about a triangle, which is, this time I'll write square root 2 as equivalent sides, legs, and 2 as my hypotenuse. And for pi by 3, and this is pi by 6, the sides are 1, 2, square root 3, correct? So now I can substitute the values. I know that tan compound angle formula is negative, and then we have tan A alpha, which is tan pi by 4, plus tan of pi by 6, correct? Divide by 1 minus tan of pi by 4 times tan of pi by 6. Is that clear to you? I'm using tan alpha plus beta formula.
Mhm.
Soon you'll remember that. Become very easy. You know what tan pi by 4 is. You know all the values, right? So we'll substitute. Tan pi by 4 is just number 1, right? So we get 1 plus tan pi by 6 is the ratio of square root 3, 1 over square root 3, right? So let me write 1 over square root 3 here. Over 1 minus 1 time 1 over square root 3, correct? With a negative sign outside, correct?
Mhm.
Now I can write this as square root 3. I could multiply both numerator and denominator by square root 3 so that I avoid this layers of fraction, correct? So what do I get? I get square root 3 plus 1 over square root 3 minus 1, and minus is outside. You see this minus outside, correct? So for the tan function, I get my result as equal to minus of square root 3 plus 1 over square root 3 minus 1. So that is my answer. However, when you check the result at the back of the book, most of the time, it will be given in the rationalized form, not exactly this answer.
Yeah.
You see the key. And so we have to rationalize it. So let me rationalize this. Means I'll multiply by square root 3 plus 1 over square root 3 plus 1. So in the denominator, I get a square minus b square, which is 3 minus 1, correct? And the numerator, I get square root 3 plus 1 whole square, because both are common, right? Square root 3 plus 1 times. So when I expand, I get a square plus 2ab plus b square. Square of square root 3 is 3. Plus 2ab means 2 times square root 3 times 1 and plus 1 square. And so I could write this as, let me now change another. Minus of the numerator here for me now is 4 plus 2 square root 3. And the denominator 3 minus 2 is 2. And let me divide by 2. And when I do so, what do I get? Minus of 2 minus of square root 3. So that is my answer for tan of minus 5 pi by 12. Do you see all this?
So did you move the 2 from the bottom?
Yes, I simplified. Correct. So 4 divided by 2 is 2. And 2 square root 3 divided by 2 is square root 3. Minus sign was outside. So all the signs changed. I have a negative number as expected since the primary, the angle was in quadrant 4, correct?
Okay.
So it may be the first question for you, part B. However, it requires a lot of calculations as you have seen on the board. You get the idea. So can you summarize how did we achieve this particular solution?
So the first thing you did was to break down 5 pi over 12 so that we could find an alpha and beta value to plug into the 10 a minus b.
Yes.
Right. Yeah.
So that exact angles can be used to evaluate the exact answer, correct?
Yeah. Okay. And then you sub the exact values in and then did the calculation.
And then we rationalize at the end.
Yeah.
So steps are simple, lot of calculations. Perfect.
Yeah.
So that is how you do this. If you want, you can share with me more questions. We can see how to solve them, right? Let's see what else you have. Okay. Can you see example cos, let's say alpha plus sine beta plus sine alpha cos beta? What should this be? Simplify. Tell me. It's easy, right? Formula. So we have cos sine, sine cos. You understand? It is a combination of two. Just add them. Sine and cos. That means we could straight away write this as sine of 3 pi by 10 plus 9 pi by 20. You get the idea.
Yeah.
This is the formula, correct? And so what do we get? We get sine of 20 is common factor, multiply by 2, 6 pi, and that is 9 pi. And that is equal to sine of 9 plus 6 is 15 pi by 12, 20. All right. And you can simplify this. So sine of dividing both by 5. So you get 3 pi by 4, correct? So that is how it could be simplified. You see that?
Yeah.
Direct application of formula. Is that clear to you?
Yeah. So in this case, we were doing like the reverse of what we've been doing.
Yes, it's the reverse. Yeah, getting back there. Can you tell me reverse calculation on this, which is tan alpha minus tan beta over 1 plus tan alpha. So, right? So that will be tan of alpha minus beta, right? So this should be equal to tan of what?
Alpha is 4 and beta is 5.
Correct. Tan of minus x. Do you see that? Which will be minus tan x. So that will be your answer. Is that clear to you?
I didn't understand the minus. Why did we add?
It's an odd function, as we explained earlier. Tan of minus x. That means you were talking about tan of minus x means here, right? Which is equal to which angle? So tan is an odd function, right? So tan of minus x is equals to minus of tan x.
Oh, okay.
That is what. Yes.
If, for example, the same question, it was like the addition version of it.
Yeah. So add them.
Then the answer would just be 10x.
9x. Then you'll add 4 and 5.
Okay.
Right. Okay. So let's clear this. Let's look into the next question. Example C. Yes. Can you try this? What is the question saying?
Find sine of alpha plus beta cos alpha minus beta tan 2a if sine alpha equals 8/17 and cos beta equals 40/41.
Direct application of the equation which you learned, right? Sine alpha plus beta, you know the formula, right? Now you say sine alpha cos beta plus cos alpha sine beta, right?
Yeah.
And you are given sine alpha and cos beta. You substitute the values and calculate, correct? So you write 8/7 sine alpha and cos beta. So when you are given sine alpha, can you find what cos alpha is? So
When you're given sine alpha, find
yeah,
cos.
sine A is given to you as 8/17, right? So you just make a triangle here. 8/17 basically means this, that this triangle has got 17 here and 8 here. So this angle here is A, right? Do you understand?
Oh, yeah.
So this side is 17 square minus 8 square square root. Is that okay?
Yeah.
So you can use calculator to find this value.
So this is Pythagorean theorem?
Yes. Similarly, for the other angle, which is B, we are given the cos value 40/41, correct? So you can find that angle, which is 41 square minus 40 square, square root. So can you find those values also? We'll write down and then we'll apply the formula, get the result. Simple as that. So first thing, solve your triangle. So in this case, step number 1, solve your triangle, correct? Means we know sine alpha, find cos alpha and tan alpha. Is that clear to you?
Yeah.
And then we have sine beta, cos beta, and tan beta. How do you do them? Pythagorean theorem. That is the first, right? So what do you get? 17 square minus 8 square is how much? Square root.
Negative 47.
No negative. 17 square minus 8 square square root. So do 17 square minus 8 square equals to square root. Answer equals to 15. Right? Similarly, do 41 square minus 40 square equals to square root. You get 9, right? So you get 9. So you have both your triangles. You see that? Now, what is cos sine alpha? Sine alpha is given to you 8/17. I'm writing here. And what is cos beta? Cos beta is given to you 40/41. We'll write here. Plus, we need to have cos alpha. So go to the first triangle. Cos alpha is 15/17. And sine beta, go to the second triangle, 9/41. You get the idea. Substitute the values. Common denominator is 17 times 41. And then we have what? Multiply these. 8 times 4, 320. Plus 9 times 15. 9 times 5, 45. And 4 plus 9 is 134. You get the idea, right? Add them up. 4, 5, 4. Over 17 times 41. Correct? Use calculator. Get your result. So like this, you can actually evaluate all the values in this particular question. Is that clear to you?
Yeah.
Perfect.
One question, sir.
Yes.
So like if you, for example, have sine alpha, can you find sine beta if you're not given it?
No.
No, right?
No. Good question. So if you have sine alpha, you can only find tan and cosine of alpha, right? That's why they'll give you one. Sometimes they also give you quadrant, because when they say cos beta is 41/41, 40/41, it is a positive value. Cosine is positive in quadrant 1 as well as in quadrant 4. So they may sometimes tell you that these angles are in quadrant 2 and this one is in quadrant 4. You see that? In that case, at present, we are assuming that all of them are in quadrant 1. You get the idea?
Okay.
Because both were positive. So our assumption is both are in quadrant 1, correct? Because both are positive in quadrant 1, correct?
Mhm.
So we are assuming that, and then we are answering. So that's good assumption. And it will give you even otherwise the right answer, but that is the assumption in this case. In the test paper, they might say cos beta is in quadrant 4. In that case, sine beta will be negative, not positive. Remember that part. You understood what I'm saying?
Say that one more time, sir.
If they say cos beta is in quadrant 4, then you have to think about the cost rule.
Yeah.
So in quadrant 4, sine will be negative. So when you write this value 9 over 41, you'll have to use the value minus 9 over 41 in your calculations.
Okay.
If they specify that this is in quadrant 4, you get the idea, which they do. Correct?
Yeah.
Anything else which you need to clarify in this question?
No, I think I'm okay.
Good. Let's move on. Take one more question. We got another 10 minutes, right? Clear all.
This is the last one for this page.
Say, read the question.
Example D, use compound angle formulae to prove that the following are equivalent expressions.
Okay, x minus pi sine. Okay, let's do it. It's very simple. I'll do one of them. So we do sine of x minus pi, right? So you could write this as sine x cos pi minus cos x sine pi, right? What is sine? Yes.
So this is the same thing as before, just using the compound angle formulas.
Yes. So sine graph is like this, right? So I'm just sketching sine graph, and also I'm sketching the cosine graph so that you're absolutely clear about what we are trying to do. So when we say pi, pi means what? This is pi, right? So sine pi is 0. Do you see that? This actually, let me write pi here, right? And this is pi for cos, which is minus 1, correct? Here, this is 0. Now, sine x minus pi is sine x cos pi minus cos x sine pi. So when I substitute the values, it is sine x, and what is cos pi equals to? Cos pi is minus 1, correct? Minus, we have cos x, and what is sine pi equals to? Sine pi is 0, right? This is sine. So multiplied by 0, so we get what? We get minus of sine x, correct? Well, minus 1 times sine. So this expression is basically equal to minus of sine x, correct? Using the, now let's do the next one, which is sine x plus pi. So if it is sine x plus pi, in that case, it will be what? It will be sine x cos pi plus cos x sine pi, right? So which will be what? Which will again be sine x times minus 1 plus cos x minus 1, right? So in this case, again, we get minus sine x, correct? Because this, yeah. So this is for sine of x plus pi, right? So it is very clear to you. You know it otherwise also. And what we are trying to say here is, if I have this angle, so we're talking about sine x minus pi, right? So from x, we are taking away pi, right? So this is negative, correct? So if you reduce, you're coming to this side, right? You see that angle, correct? X minus whatever the x angle is. This is x, right? So from x, if you take away pi, then you land up here. Because this is x, right? So this is x minus pi. Do you understand? Negative. Yeah. Similarly, if I do x plus pi, then this is x, and you're going in this direction, plus pi, you land up here. Do you see that? That is x plus pi. You'll end up at the same line. Do you see that?
Yeah.
Now let's do cos of x plus pi by 2. Expand it. What do you get? Cos of x plus pi by 2 is cos x cos pi by 2 minus sine x sine pi by 2. Apply the formula, nothing else. So it is cos x. And what is cos of pi by 2? We know cos of pi by 2 is 0, right? Minus sine x. And what is sine pi by 2? Sine of pi by 2 is 1. So we again get minus sine x. You see that? So all the three expressions are actually equal to minus sine x. The last one is the co-function identity, correct?
Okay. So can you explain one more time to me, sir, where you get the values from, like the -1 and the 0?
Okay. Using the graph, I get the value, see, sine function. It is 0 for sine 0. Pi by 2, it is 1, correct?
Mm-hmm.
For pi, it is 0, correct?
Mm-hmm.
So I use those values. Sine pi by 2 is 1. So I use 1 here. On the other hand, sine of 0, sine of pi is 0. So I used sine 0 here, right? In these two expressions. And for cos, we know cos of pi is -1. And so I've used that -1 for cos of pi, and I got my results. Do you see that?
Okay, so you need to remember like the x and y values of the sine and cos graphs.
Okay, very easy to remember. Just draw this sine curve, or even simpler is use the quadrants. Okay, now in the quadrants, let me show you how. What is this coordinate of this point here on a unit circle? This point is 1, 0, right?
Yeah.
And this point is 0, 1, correct?
Mm-hmm.
This point is -1, 0, correct?
Mm-hmm.
And this point here is, it is 0 and -1, correct?
Yeah.
Any point on the coordinate plane, unit circle I'm talking about, let's say any other point, will be what? Let's say, eliminate point P is cos x sine x, right? Cos x is the distance. If r is 1, then it is the x value, correct?
Mm-hmm.
So any coordinate point actually gives you the x value and the y value. So if you look at x-axis, unit circle, intercept, 1 is the cos value and 0 is your sine value. As it moves, see, cos starts with 1, right? As it moves, goes to pi by 2, you see the value becomes 0, which is here. And then -1, and then 0, and then 1. So that is one full cycle. And that is how you get those 4 points. You understand? And these are the key points for our cosine and sine functions. So these are the 4 key points on the unit circle, which are the intercepts of x and y axis. You see that?
Yeah.
So easy to remember. Just look at the coordinate plane. X value is cos theta, right? So any point P, let's write down a note here. So any point P which has x and y values, basically it is r cos theta and r sine theta. Is that okay? Where r is x squared plus y squared. Let me make a triangle here, right? If this is x, this is y, and this is r, what is r? Right angle triangle. R is equal to square root of x squared plus y squared.
Yeah.
However, if x and y is, if r is 1, then, r square is also 1, correct? So we get r is 1, then we get cos theta sine theta straight from the point itself. So that is how you will be doing it. So is this concept absolutely clear to you?
Yes. 1 second, sir. I'm just going to take a picture.
Yes. And go through this video. I'm going to upload this video on YouTube. Watch it, and then we'll take up all other questions which you have on this particular chapter.
Okay.
Okay. You can also practice from my YouTube channel. Just type Anil Kumar compound angle playlist, and you'll get hundreds of videos. Can you do that? We can just stop sharing that. Just type out and see what you get. Yeah, you can share the screen. Type Anil Kumar compound angle playlist.
Oh, yeah. 1 second.
You will see hundreds of videos, and then I'll tell you which ones to select, and you can watch some of those videos. They will help you.
Okay.
What you have to remember is the compound angle formula and how do we derive all other related formulae from there. So once you practice that couple of times, solving questions will be very easy. You get the idea. See, so we have trigonometry, compound angle formula, connection. So this 46-minute video is exactly what we talked about today. And it has many other related formulae which has been derived in this video. Is it okay? So
Okay.
that's a must to watch. And then any of these playlists, we have got hundreds of these playlists on this chapter, which actually you can actually watch any one of them, right? So that video was made with another student, Emmy in UK. You can watch that video. This will give you a lot of details about compound angle, right? How it is, and we have connected it with the double angle just as we did initially in our lesson also today, correct?
Mhm.
And we are also talking about sum to product formula and from product to sum formula. So both ways. That product to sum formula is a test question, which is so many times asked in the test paper. So that'd be worthwhile. So I'll recommend you watch this particular video 46 minutes after our class today. Is it okay?
Okay. Sir, do you have like a practice test question?
Yes, I'll send you a link, but here you just go through this or just go further down. Okay, just type compound angle test. Yeah, and so you will now see many questions related to test papers. Is that clear to you?
Okay.
So that is double angle assessment review. These questions are actually from test papers, right? Move further. And this is a apply compound angle test 1, right? So the next one was like test 1. So when you type test, you will get all the test questions.
Okay.
Sometimes you get the whole test paper. Go further. So that is trigonometric identities based on compound angles and review. Yeah, practice test. This playlist has only the questions from test.
Okay.
One test paper will discuss as a whole. Do you see that these are the questions from a test paper? As you know, first 10 questions are multiple choice. So that is how they ask them, correct? And then we'll have all other questions which are related to test paper. I think that will be a good playlist for you. Those 27 videos will be excellent.
Okay.
Okay, so get ready for, we'll have a fast track class next time when you'll have to answer about 25 questions on this topic. Are you ready for that?
Yeah.
Yeah, you will try that next time, right?
Yeah.
25 questions in 30 minutes.
That sounds, yeah. I also have the other units I wanted to cover too.
Sure.
I don't know if we have time today, but
we can do it next time, but show me. Yes, no problem.
Yeah, so double angle for which we touched on a little bit today.
Little bit, yeah.
Yeah, and then also just the proving identities.
Oh yes, we'll do that. So for sure, we'll do that in the next class.
Okay.
Great. Okay then. Thanks for sharing and all the best.
Okay, thank you, sir.